Hello guys, welcome back to my channel, and in this video I'm gonna talk about how the adapters that we use in our daily lives work. Yeah, I know that everyone use adapters like as if they're granted from the heaven. They never care, most of the people never care about how it works. But today I was just curious to know how it works because I was like, hey man, I have been using it for years. And though I never thought about the working behind it, I was curious to know about it. I really wanted to know how does it work. Uh, when I get energy, when I get electricity from the socket, why not use that energy directly and charge my phone just through a cable? Why to use an adapter? What's the function of it? Why we need it? Why we use it? And how? And if it does its job, how does it do? How it does the job? I was so curious about these things. I just got triggered about this thing within a few seconds. So I just started my research. And as a result of my research, I stumbled upon a lot of things. I realized and understood a lot of scientific facts. And and I'm here to share the thoughts I have, to share the information I have got with you. Yeah, I think this is the right moment to share the right information with the right people. Yeah, let's get into the details. Let's get into the topic. So, starting with adapters. So, before getting into the adapters, I think we need to start looking at the phones. So, we know that we have phones and we use our phones to play games, to call people, to chat with other people, to see, to watch, to use social media, and for other purposes. So for the phone to perform all these functions, it needs energy. How does it get energy? It gets energy from the power stored in the phone, in the battery. So how does the battery get charged? It gets charged from the electricity that is taken from the sockets that are present in our home, right? And yeah, we are going to talk about how the process of charging, how the electricity reaches, how the electricity from the power socket charges your phone, what happens in between that journey. That's what we are going to digest. So let's start it. So I know that you have seen the adapters, right? So what's inside it? That was the first question. That was the first doubt I had. Why we need to use it? So I started searching about it, and I realized that the electricity that we get from the socket, from directly from the wall, is about 230 to 40 volt. This is too high. We need to realize that it is 230 to 40 AC volt. But at the same time, our phones or digital devices are designed to work on low voltage DC current. So I think you got it. So in this situation, we need to transform the electricity that we have from the socket into a small current, which can be used to power up the digital devices that we have, right? So that's what I'm gonna explain. So, what the adapter does is that the adapter takes up the 240 volt charger as or 240 volt AC current, and it just provides this current electricity to a rectifier circuit. Rectifier circuit is an electric circuit which consists of diodes. Diodes are some electric components, and so there is a rectifier circuit, and this rectifier circuit does the job of converting this AC current into DC. Yeah, so we will get as an output, we will get a high voltage DC current. So when we get a high voltage DC current, but here the problem is that this is not a pure DC. This is a pulsating DC. So we know that AC current is like this. It's like a wave. We want to convert this wave into a straight line. That's what we are aiming for. But the pulsating DC is like small. It also has some forms of small. It also resembles small waves. So we need to eliminate it. That's what we are aiming for. So in this case, what we are effectively going to do is the following. We will take the pulsating high voltage DC current provided by the rectifier circuit, and we use that current and provide it to a filter circuit. Filter circuit consists of capacitors and diodes. It is also another electric circuit. So this circuit does the job of smoothing the DC. Yeah, so finally we won't get a pure DC. There will be imperfections in the real world, right? So yeah, surely there will be imperfections, and we will get we will get a current which almost resembles the DC, the pure DC. So, but the problem is that still the current we have is high voltage DC current. I told you that we need low voltage, which is approximately 20 volts. If you want to use it to work with the electronic circuits that we have, if you want to charge our phone, we need to reduce up the current. We need to reduce up the electricity to that level. If it does, so I think you got it. So we need to get to that level. So how can we do it? That's the question here. So we will be using some special devices, some special technologies which have been implemented in our in the adapter circuit, and that is SMPS, which is switch mode power supply. So this is a new technology which is used instead of simple transformers, which was used in traditional adapters, which make the traditional adapters huge and messy. But in the case of switch mode power supply, it just makes the work so effective, and hence the adapter what we are working with is small and so that's how the things are. Yeah. So uh, that's how, and it works so efficiently in the case of it. So that's how the things are, and then also after converting the electricity into after converting the electricity into a low voltage DC current with the help of SMPS, we can now use it to charge our phones, for charge to work with our devices. So now I think you got the journey how a high voltage AC current is used to create low voltage DC current. This is the journey behind it. There is a lot of procedures. It's not magic. It gets done with purpose. There are a lot of things working behind it. There are a lot of brains and designs which have been working behind to make this happen. So I hope you got a better idea of it and understood the complexity and simplicity of this. So so I hope you really enjoyed this video, and I'm wishing to see you again the next week. So see you guys. Okay, bye bye.